perchlorates, rocket fuel, and why we need to look at Mars. In the comments of the Mars tardigrade video, there were a lot of questions on perchlorates, so I want to try to explain some more about them and what exactly is happening on Mars and the health effects on humans. So what are perchlorates? It is a single chlorine atom with 4 oxygen atoms. Its uses here on Earth are mostly for rockets, missiles, and fireworks. It is one of the main oxidizers used. The perchlorate supplies the oxygen in the propellant. It is the highest oxidation or added oxygen for chlorine. The others are hypochlorite that has 1 oxygen, chlorite that has 2, and chlorate which has 3. Now in rocket fuel it is normally in the form of ammonium perchlorate. Ammonium is NH4 and perchlorate is ClO4-. Put together that gives us NH4ClO4. Ammonium perchlorate is the oxidizer. Aluminum powder is the fuel. In many solid rocket motors, those are mixed with a rubbery polymer binder, making a composite solid propellant. Again, think rockets, the space shuttle boosters, even military missiles. In fireworks, it is normally potassium perchlorate, with other metal salts to give it the colors. And yes, all of these cause pollution. It is a major source of pollution in our waterways after a fireworks show. Perchlorate is very stable, and it can take years for it to break down. And it takes high heat, ionizing radiation, or UV to break it down. And when it does, it can become some bad things as stated in the tardigrade video. Perchlorates are formed in different ways. They can be formed naturally. Chlorine from sea salt, salty dust, volcanoes, or pollution can be changed by atmospheric chemistry. UV light, ozone, and lightning-like reactions can slowly push chlorine into more oxygen-rich forms, eventually making perchlorate. We can also make it ourselves, mostly using electrolysis. The main issue for human health is the thyroid. Perchlorate can block iodine from getting into the thyroid. Your thyroid needs iodine to make thyroid hormones, so too much perchlorate exposure can be a problem, especially for babies, pregnant people, and anyone who already has low iodine. The thyroid hormones impact how your body uses energy, so your metabolism. It can affect heart rate, breathing, digestion, body temperature, brain development, mental activity, skin and bone maintenance, and fertility, so it is very important. Some occupational and animal studies also raise concern about inhaled perchlorate dust irritating the respiratory system. But human worker results are mixed and depend on exposure level and iodine status. Now, the EPA gives 0.7 micrograms per kilogram body weight per day, or 0.007 milligram per kilogram per day as a reference dose, meaning this amount is not expected to cause adverse health effects. And that brings us back to Mars. Mars has perchlorate mixed in its soil, as I mentioned in the tardigrade video. That matters because Martian dust is already a problem for humans, and perchlorates just adds another chemical health hazard. So how much does Mars exactly have? For Mars soil, Phoenix measured about 0.4 to 0.6% perchlorate by weight in Martian regolith. So in 0.1 grams of Mars soil, there is 400 to 600 micrograms of perchlorates. The EPA says that the upper limit for people ages 12 and up for ingesting Earth soil is 0.1 grams, so that's why we're going to be talking about the soil in that amount. I have a chart here that shows by body weight how many micrograms of perchlorates is safe for that body weight, and how many more times perchlorates are in only 0.1 grams of Mars soil. That means even small, repeated amounts of Martian dust getting into food, water, or lungs could exceed a health-based daily reference dose. So dust control, filtration, washing, and perchlorate removal would be non-negotiable. Now, there was a bit of confusion on my last video for some people. When perchlorates get UV radiation, they break down into other forms. Well, one of those forms is hypochlorite. Some might know sodium hypochlorite, and that is bleach. It can also make radicals OH, Cl, OCl, all extremely damaging to membranes, DNA, proteins, and enzymes. So if it is this bad, why are we even trying to go? Should we just give up? No. Here's the thing. As I said, we have this type of pollution all over. It is found everywhere. We need a better way to clean it. If that comes from research to get to Mars, fantastic. But are we going to be living on Mars anytime soon? No. And we need to make sure we check off all of these boxes before we even attempt to put people up there. Like, are there some bacteria that actually use perchlorates and break them down by giving up the oxygen? Can we use those bacteria? As some is actually mentioned in the comments. Well, NASA Ames researcher Lynn Rothschild is actually working on that exact idea, to use engineered Bacillus subtilis in a contained bioreactor to reduce perchlorates and chlorates into chloride and oxygen before Martian water is used for drinking, farming, or propellant production. See, that is why we look up. The technology we make to go there will be the same that saves us here, but we have to be honest about it and not let someone that is trying to get a higher stock value to make people think that this is actually just around the corner. It isn't, and it won't be for a very long time. Till then, we have to take better care of what we have here. That is what good science communication is all about.